Hello and welcome to eMind Technology, the module OSPF on NBMA network. OSPF on non-broadcast multi-access environment. Now, OSPF for non-broadcast environment configuration is quite different from OSPF on a broadcast environment. LAN environment we can call it as broadcast. WAN environment we call it as non-broadcast. Now OSPF for non-broadcast multi-access environment configuration is quite different. Behavior of OSPF is quite different. Hello timers are different. Neighbor relationships are getting, they are in different fashion. They form the neighbor relationship. Quite a lot of differences in OSPF in NBME network. So those differences we are going to learn in two videos. So this I call it as OSPF NBME network part 1 and later part 2. Part 1 will have the frame relay configuration because it is non-broadcast environment. The frame relay configuration part I want to show you in part 1 of NBME network, OSPF NBME network. In part 2 of NBME network OSPF, I will be teaching you 5 different types of OSPF NBME network. Alright, so this is what we are going to see. Now what is the non-broadcast environment? Look at this, this for router 4 is what we are going to convert as a frame relay switch. When I make it as a frame relay switch, it becomes a non-broadcast environment. In non-broadcast environment you need a frame relay, so I configure that router as a frame relay switch. This is not going to do the router function. Now what is non-broadcast? If I send a broadcast, if it is not going to reach the other end, then it is non-broadcast environment. If you take a LAN, if you send a broadcast, definitely it will reach all the other part of the network. Whereas if you send a broadcast in a WAN environment, definitely it is not going to reach the other end. Why? You have a lot of routers in the middle which is going to stop the broadcast, and WAN is also huge. Your broadcast cannot go and reach there. That's why we call it as non-broadcast environment. Non-broadcast.
So huge means what?
Now let's see the frame relay configuration part. See, I'm going to R1. By default, we know that interface serial, show interface serial 1/0. The default encapsulation type is HTLC, but we are trying to do NBME network with frame relay. So I go under interface serial 1/0 and say encapsulation frame relay. This changes the encapsulation type. Now let us verify. Same command again. Now you see on serial interface serial 1/0 you have encapsulation type as frame relay. Changed. So let me pause the recording and do the same configuration on R2, R3 and R4. Encapsulation frame relay under this interfaces, right? So on R2 I have given encapsulation frame relay, likewise on R3 also it is given, and R5 also given. Then now our part on router side is over as for now. Let us go and learn how to convert a router to be a frame relay switch. In the cloud I have kept a router called R4. This is what we are going to convert as a frame relay switch. Now if you see on frame relay switch I have connected to 4 interfaces, serial 1/0, 1/1, 1/2 and 1/3. Now I need to put 3 PVCs because I have 3 clients, or I can see multi-access, 3 access to a server, to the hub. This is hub and these are all the spokes. I have 3 routers, so I need to put 3 PVCs to this branch offices. Let's consider this branch offices. Now how can I convert a router to be a frame relay switch? The very first command is frame relay switching. This is the command that converts the router to be a frame relay switch. You know about the global configuration mode. Whatever we do configuration on the global configuration mode, it affects the entire router. I said frame relay switching, so it converts the router to a frame relay switch. Now this is a frame relay switch now, and now I go to each and every interface like serial 1/0 and I say no shutdown, and then I give clock rate. Why I give clock rate? Because it's a frame relay switch, it's a DCE device. So I need to give clock rate. I'll say 64,000, and then next command is encapsulation frame relay. I need to give, after giving clock rate, encapsulation frame relay. And next command is frame relay INTF type, means frame relay interface type. I'm going to say it is a DCE device because it's a frame relay switch, so you need to hard code it as a DCE device. Right, now these are the common commands that we need to type. So first command, no shutdown, second is clock rate, and then third is encapsulation frame relay, and then DCE. So do not forget, we also need to give frame relay switching on the global configuration mode. Alright, now what I'll do, I'll go to the other interfaces like 1/2, 1/1 and 1/3 and repeat the same configuration. So instead of typing again and again, I can copy and paste it. Show running, I have done on one interface which is serial 1/0. So I'll copy these three and then I'll paste it. This is not actually V typed, it is default one. It is there in everything. So I'll just copy, nothing wrong. I'll copy and paste it to the other interfaces. So going to interface serial 1/1, no shutdown, paste it, run. Next, going to another interface 1/2, no shutdown, paste it. One more interface 1/3, no shutdown, paste it. Right, now we have done the basic configuration for frame relay. Now we need to put PVCs. Now I go under the interface serial 1/0 and say this command, frame relay route command. This frame relay route command we use only on the router on which you convert as a frame relay switch. You don't have this command, frame relay route command, on client routers, on head office or branch offices. There, if you want to write a static frame relay map, you will have frame relay map command, not the route command. This is frame relay route.
What is the difference?
Which is this frame relay route, which is helping to create a PVC. Frame relay route helps to create a PVC. Frame relay map is not creating PVC. It is mapping the router to a PVC. That is just mapping. So this is what real PVC. Now frame relay route, what is the DLC number I have? First DLC number is 100 on this interface. First DLC number is 100. So I say 100. Okay, that PVC is having exit where? Exit on interface serial 1/1. So the PVC starts from this 100 on this interface. The end is on serial 1/1. What is the DLC number there? 150. So this is must, right? Enter. Next, we have two more PVCs to be done. What is that? Frame relay route 200. What is the exit interface? Serial 1/2. What is the number of that exit interface? 250. Next, frame relay route 300. Exit interface is serial 1/3, which is 350. Right, now you have done one side. The other side, interface serial 1/1, frame relay route 150. What is the exit interface? Serial 1/0. From this direction, the opposite direction, 1/0. DLC number is 100. This is done. One another interface serial 1/2, frame relay route 250. Exit interface is serial 1/0. 0. 1/0. What is the number? 200 is the DLC number. Then next interface serial 1/2 3 frame relay route 350. Exit interface is serial 1/0 300. Then now I have given frame relay configurations. Now let us go and verify show frame relay route. Look at this, all are active. Active is good. Yes. Means your frame relay is pakka. Now let me go to router 1. I'm on router 1 now. Now if I type show frame relay map, I should see 3 maps. Yes, I'm seeing 3 maps. In order to go to 10.0.0.2, the DLC number that we need to take is 100. In order to go to 10.3, which is router 3, the DLC number is 200. So frame relay is working pakka. So only this much is a frame relay configuration. Very simple. To convert a router to be a frame relay switch is only this much. So in the following video, I'm going to teach you how OSPF behavior in NBMA network. There are 5 different modes of NBMA network. I'm going to teach you in the following video. OSPF part 2, non-broadcast multi-access environment. Alright, thanks for watching this video. Hope you understood how to create and how to configure frame relay on a router. See you in the next video. Bye bye.